Hello friends, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video I am going to talk about kinetics of chemical reactions. So how the rate of reactions depends on temperature and constant K. As a rule, when the temperature increases, so does the rate generally. For every 10 degrees Celsius increase, the rate double. Look at the following rate equations. Rate is equal to constant K, concentration of A and concentration of B. So if we increase the temperature of A or B, what happened to the concentration? Nothing. Therefore, the temperature only affects K, temperature and K. Because K varies with temperature, it can be used to compare the same reactions at different temperature. So temperature K, rate constant 633, 666, 697 as 615. You can see the rate changes. So what can be deduced from the table? As temperature increases, so does the value of K. This only works if the concentration of the reactants remain the same. Now friends, remember, temperature is a measure of the average kinetic energy. You know, particles will only react if they collide and have enough energy to start breaking bonds. I repeat, particles will only react if they collide and have enough energy to start breaking bonds, and this energy is known as activation energy. You can see the graphs at different temperature, 300 K and 310 K, the shifting of the maximum. So only the particles above activation energy will react. Notice there are more particles above activation energy at the higher temperature. So friend, temperature dependence of the rate constants. So K is equal to A dot exponential minus A divided by RT. This equation is known as Arrhenius equations. A is the activation energy joule per mole. R is the gas constant 8.314 joule per Kelvin per mole. T is the absolute temperature. A is the frequency factor. So ln K is equal to minus EA by RT plus ln A. So ln K is equal to minus EA by RT plus ln A. You can see the graph, linear graph, ln K versus 1 by T. Now friends, what is the collision theory? For any reactions to occur, molecules must collide with each other. Once molecules collide, they may react together or they are not. Molecules must have sufficient energy and molecules must have correct geometry. So you can see here in these reactions O3 plus NO, both are gas and giving O2 gas and plus NO2 gas. So now you can see NO and O3 making the transitions and then the formations of OON. Now activation energy and the activated complex. Energy barrier to the reactions. Amount of energy needed to convert reactants into the activated complex. The activated complex is a chemical species with partially broken and partially formed bonds, always very high in energy because of partial bonds. Now, these two graphs indicating exothermic reactions and endothermic reactions. Potential energy versus reaction progress. You can see the activation energy, and activated complex here you can see the activation energy. So here activation energy is less, here activation energy is maximum. So in this case energy needed for the reactions, and in exothermic case energy released from the reaction. So friends, the activation energy is the minimum amount of energy required to initiate a chemical reaction. Now what is the reaction mechanism? The overall progress of chemical reactions can be represented at the molecular level by a series of simple elementary steps or elementary reactions. The sequence of elementary steps that lead to product formations is the reaction mechanism. You can see here 2NO plus O2 gave 2NO2. N2O2 is detected during the reactions. So elementary state NO plus NO give N2O2 and plus N2O2 give plus O2 give 2NO2. So our all reaction is 2NO plus O2 gives 2NO2. Now what is the intermediates? Intermediates are a species that appear in a reaction mechanism but not in overall balance equations. An intermediate is always formed in an early elementary stage and consumed in a later elementary stage. So NO plus NO give N2O2. N2O2 plus O2 give 2NO2. So 2NO plus O2 give 2NO2. The molecularity of the reaction is the number of molecules reacting in an elementary steps. So unimolecular reactions, elementary step with one molecules. Bimolecular reactions, elementary step with two molecules, and termolecular reactions, elementary steps with three molecules. So friends, factors affecting rate of chemical reactions: temperature, concentrations, pressure, surface area, presence of a catalyst. So factor 1, temperature. Temperature increase in temperature, increase in kinetic energy, increase in number of collisions plus increase in number of particles with greater than required amount of activation energy. Then more particles react, increase rate of reactions. So put on your thinking cap. Can you explain why food should be kept in deep freeze compartment in order to ensure its freshness? Answer is like that. The low temperature slow down chemical reactions, which makes the food turns bad. So second factor is concentrations and pressure. High concentrations and pressure, more particles per unit volume, increase in frequency of collisions and rate of reaction increases. Now Factor third, surface area. Increase in surface area and particle size, increase in exposure to the other reactants, increase in probability of collisions, and increase in rate of reaction. And factor fourth, presence of catalyst. It speeds up the rate of reactions through lowering activation energy needed for reactions to occur. Think what can you infer from the above statement. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.